Dear students, welcome to this class. In this class, we are going to discuss about yet another important topic in thermodynamics, that is dq, change in the heat content, work done, W, dE, change in the internal energy, dH, change in the enthalpy for van der Waals or real gases under adiabatic condition. So van der Waals gases obey only the van der Waals gas equation, that is P plus A by V square into V minus B, which is equal to RT. So already we have discussed about the same values for the ideal gases under the adiabatic condition. Now we know the first law equation, thermodynamic first law equation, D is equal to dq minus W. Since the condition is adiabatic, so the value of dq becomes 0. Therefore the equation becomes D is equal to minus W. That means if you are working out for the dE, then just to change the sign, then that value becomes W. Now to derive this, we are going to take this relation, that is energy, internal energy is a function of temperature and volume. So now differentiate this equation. Now the value of D is equal to dE by dt at constant volume. This is the first term, differentiate with respect to temperature. And the second term, differentiate with respect to volume. So here differentiating this with respect to volume, the second part. So dou E by dou V at constant temperature. So naturally temperature become constant into dou V. And we know that the first term dE by dV dt at constant volume, this term is nothing but is equal to CV, that is heat capacity at a constant volume. Therefore this equation becomes D is equal to CV dt plus dE over dV at constant temperature into dV. Now this one more term is here actually, that is this term. Now this term, that is dou E over dou V at a constant temperature, is equal to A by V square, that is the correction factor, volume correction factor, A by V square. So the equation becomes D is equal to CV into dt plus A by V square into dV. Now we are going to integrate this equation between the limits E1 and E2, that is the initial energy, internal energy, and the final internal energy E2. Similarly, initial temperature T1 and the final temperature T2. Similarly, the value of volume V1 and V2. Okay, the initial volume and the final volume. So this is the relation, integral part. So here we are taking the CV out because it is a constant, that is heat capacity at a constant volume. Similarly, A is also a constant, so it is taken out. So integrating this equation, 1 by V square into dV here, this part. So A and CV are the constant here. Now let us find out the solution. So this is the equation. So the solution for this equation is CV delta E is equal to CV into T2 minus T1. So naturally 1 by V2, this becomes minus 1 by V2 minus 1 by V1. So this plus sign becomes minus. So minus A into 1 by V2 minus 1 by V1. So this is a solution for this equation. Or in simple, this is the value of delta E. So we know the value of delta E. So the value of delta E is equal to CV into T2 minus T1 minus A into 1 by V2 minus 1 by V1. And we know that delta E is equal to minus W. So naturally we have to change the sign in this equation. So W is equal to minus CV into T2 minus T1 plus A into 1 by V2 minus 1 by V1. So this is the value of W. Now finally we are going to work out for the delta H. For this we are going to take the delta E equation. This is the delta E equation just we derived. And we know the relation between the delta H and delta E. Delta H is equal to delta E plus P into delta V. Right now, we know that P delta V is equal to R into delta T, because we know that P is equal to RT. So this equation P delta V into R delta T. So naturally, the value of delta H is equal to delta H is equal to delta E plus R into delta T. So delta E is plus R into T2 minus T1. Now substitute the value of delta H from here in this delta H value to this equation. So delta H is equal to Cv into T2 minus T1 minus A into 1 by V2 minus 1 by V1. Right, now just add the value of R into T2 minus T1. Right, now we know the relation between Cp, Cv and R because we are having two T2 minus T1 terms are there, Cv into T2 minus T1. Here also R into T2 minus T1. So Cp is equal to Cv plus R. Therefore, we are going to remove the first and the third term by the relation delta H equal to Cp into T2 minus T1 and minus A into 1 by V2 minus 1 by V1. So this is a relation for the delta H. So delta H values, this is the value. So in this part, we discussed about the value of dq, w, de and dh for van der Waals gases. Thank you.